In this video I explain how Teradata sorts the rows of your result set and how this affects the performance of your SQL queries. This is a short video from a series of videos that aim to provide you with the most important information about Teradata in the least amount of time. Please also visit our website www.dwhpro.com for more information and details. Have fun. When sorting a table, probably the technically easiest method would be to move all rows of a table on one Teradata AMP before doing the sort. Of course, Teradata cannot use this method because the parallelism of the whole system would suffer enormously. Let's not forget that Teradata systems consist of hundreds or even thousands of AMPs that can work simultaneously on different table rows. Copying all rows to one AMP to sort them would be a non-scalable operation and a bottleneck. Teradata makes optimal use of the shared nothing architecture also when it comes to sorting rows. Sorting is done in parallel at each level of processing without the need to redistribute rows. Sorting is always the last step in an execution plan. Let's look at the sorting process in detail. It is used, for example, when your SQL query contains an order by. At first, the table rows are sorted on each AMP where they reside. A higher number of AMPs permits a higher sort performance as all AMPs do the sort in parallel. The sorted rows are put into a spool table. After AMPs finish their local sort step, Teradata will return the local spools to the requesting client. For performance reasons, Teradata creates a global buffer per node and additionally on the parsing engine level and informs the client that the result set is available. The client tool fetches as many rows as needed. Recall that we often abort requests after having a specific number of rows available in SQL Assistant. Each fetch request causes each AMP to move its top row into the buffer, where they are merged globally in sort order. Subsequently, each AMP puts its next row into the buffer, where they are merged, preserving the sort order. This process continues until the global buffer is packed and sent via the attached network to the client. The merge process itself is done by the Binit software, which handles the merge buffer on its own. The above described process continues as long as the client fetches rows from the result set or no more rows are available. The excellent performance of this sorting algorithm results from two properties. First, the AMP local pre-sorting step is done in parallel on all AMPs, and sort performance increases with the system size. This provides good scalability. Second, Teradata must sort only the client-requested rows in the last global merge step. Usually, when the whole table is requested from the client tool, such as SQL Assistant, we cancel the request after having a small number of rows on our screen. It would not make sense to do the global sort for millions of rows that never are noticed by the user. I hope with this short video I could give you a good insight how data is sorted in Teradata. We have reached the end of this video. I hope you learned something new and can use it in your daily work with Teradata. If you liked our video and would like to see more or have any questions, please leave us a short comment. And please don't forget to give us a like if you liked the video. It's very important for us to get feedback to see if we should expand this video series. Thanks for your feedback. See you soon.